Hello everybody, so today we are starting our next topic, which is looking at graphing simultaneous equations. So basically solving simultaneous equations and fitting the linear model in real life contexts. So remember, simultaneous equations are basically where we've got two or more equations that we sort of graph and we find their intersection point. So the intersection point is if I've got my set of axes, I've got two lines, the point at which those lines cross each other. So in terms of simultaneous equations, a lot of the work that we'll be doing is stuff that was done in 2.5, okay, so chapter 2, where we're looking at graphing and finding now the intercept. So that x and y coordinate that we calculate is actually the intercept point of these two graphs, and looking at how these apply to real life situations. So in terms of graphing and solving simultaneous equations, okay, simultaneous equations we know can be graphed on a Cartesian plane, on the same Cartesian plane or axes. And whenever you see the word solution, solution is basically referring to where those two lines intersect, so the coordinate at which they intersect. So here we've got our orange line and our blue line. Our solution would be at this point here, 1, 5, where the x value is 1 and the y value is 5. Okay, so for the graph on the right, the point of intersection of y equals x plus 4 and y equals negative 2x plus 7 is at the point 1, 5. So the solution to the simultaneous equation is x equals 1 and y equals 5. Okay, which is what we'll be working on. We just have to keep in mind though, not every pair of simultaneous equations will have an intersection, okay, so because simultaneous equations are basically two lines, so if they have the same gradient, if they are parallel, they're not going to have an equation, okay, a solution. So something like y equals 2x minus 5 and y equals 2x plus 13, they both have a gradient of 2. Okay, a different y-intercept but still the same gradient, they will have no solution, okay, because they are running parallel to one another. A lot of the work that we're going to be doing with this topic is going to be using our CAS. So if I have a question, okay, my question might state graph and solve the equations y equals 3x take away 2 and x plus 2y equals 10, okay, we are going to be asked to solve it. So solving basically just means finding the intersection. Okay, and the intersection is the point at which those two lines cross each other. So the steps that you need to follow on your calculator, I want you to have a go with these two equations here. Okay, we've got open a new document with the graphs page. In the entry line with the prompt f1x, okay, I want you to type the first equation, which is 3x take away 2, and click enter, and you'll see what we've got on the right hand side over here. Step 2 is then typing in our second equation, okay, but remember when you type in an equation into a graph, it needs to be in the form y equals, so we just need to rearrange this, okay, so you can rearrange it on solve, okay, so solve x plus 2y equals 10 comma y, because we're solving for y, or we can just rearrange the equation. So basically we subtract x from both sides, we're going to get 10 take away x, okay, and then we divide it by 2, okay, so we're going to end up with 10 divided by 2, which is 5, take away x on 2, which is what they've written here. X on 2 is the same as me writing half x, so we're going to write this, okay, into our graph page. So we then, in order to do that, we have to press Ctrl G to view another entry line and then type in that second equation and then click enter. So you can use the up down arrow keys to move from one entry line to the other, but what you should end up with is two lines, okay, like this. So both of the graphs are there for you, and what we're trying to find now is this intersection coordinate. So in order to do that, once you've put both of your equations into your graph, you need to click menu, press number 6, which is analyze graph, Okay, and then you need to select number 4, which is intersection, and then click enter. And what you should end up with is a touchpad, okay, that allows you to move the lower bound line to the left of the point of the intersection and then press enter, and then use the right key to move to the upper bound line to the right of the point of the intersection. So on this side we're looking towards the left, on this side we're looking towards the right, and then we're clicking enter. And what should come up is our intersection point, which is 2, 4. So if our coordinate is 2, 4, that means we have an x value of 2 and a y value of 4. Okay, so that is how we get our answer using our CAS. You will be able to have a go at practicing that with the questions in a moment, but following these steps is really important. So if you don't get this, please send me an email. All right, next bit is looking at modeling with simultaneous equations. So each equation that we come up with actually represents something that's a real life scenario. So simultaneous equations can be used to solve problems including linear modeling. Okay, so what we were looking at last lesson with converting worded problems into actual linear equations. So you might be required to graph both equations on the same set of axes in order to solve the problem. Okay, so steps for solving worded problems. We need to firstly make sure we read the question carefully, identify what our unknowns are, and assign a pronumeral, a letter for each of them. So this is defining your terms. So C stands for cost, P stands for number of people. We then have to set up the equations by converting the given information into some sort of mathematical sentence. Okay, so it might be saying y equals 2x plus 3, defining that x stands for this, y stands for this. All right, we will then solve the simultaneous equations using our CAS or using substitution and elimination, and then checking the solution at the end. Okay, and then finally, if it's a worded question, answering our original question in a sentence. Okay, with our variables, we need to make sure that we're using the units correctly as well. All right, so here we have got a question. The cost and revenue equations for the super products company has been given. So we've been told that cost is V equals 2,000 plus 5x over 3, and revenue equals 15x, where V is the money measured in thousands of dollars, okay, and X is the number of units sold. So we need to identify, firstly, for part A, what are the slopes and the vertical intercepts of each of the equations. So if we look at slope, slope is our gradient value, and vertical intercept is our C value in our y equals mx plus c. So remember, your gradient always comes before the x value, and the value on its own, the constant term, is your C value. All right, so having a look at this one, if we look at the first one here, okay, our gradient would be what comes before the x, which is 5 over 3. So m equals 5 over 3, our slope, and our C value, okay, our vertical intercept, would be 2,000. All right, looking at this next one, okay, our slope, our gradient is what's built for the x, so our m here is going to be 15, and our C value, okay, our vertical intercept, there's nothing there, so it's going to be 0. We have then been asked to graph both of the equations on the same set of axes, so you would use your CAS calculator, okay, and put in both of those equations, making sure to follow those steps from up here, okay, making sure that you do your first equation, okay, and then to get your second equation, you need to do Control G, type in your second equation, and then click enter, okay. And then we have been told the break-even point is the point where the cost equals the revenue. So basically, where this first equation equals this second equation. So we are basically finding the intersection point, okay. So you can use those instructions above, okay, where we have to use the process to find the point of intersection. Click menu, number 6, number 4, enter. Scroll your mouse to the left-hand side, scroll your mouse to the right-hand side, and it will tell you the coordinate. Okay, so once you've got that coordinate, that is the break-even point. Okay, so when you get your x value and your y value, so have a go at doing that in your calculator. You should end up getting 150,2.25, which basically means that the break-even point is at sales of 150 units, where both the cost and revenue are $2,250, because remember, our V is measured in thousands of dollars, so you've got to convert that into $2,250. All right, the working out, of course, is here, so you can see that graph, okay, and that point of intersection would be at 150,2.25, and you can have a look at that. All right, another example. The length of a rectangle is 3 times its width. If the perimeter of the rectangle is 52 centimeters, find the dimensions of the rectangle. So, what do we know? We know that we've got a rectangle. Okay, we know what shape a rectangle is. We're going to let L equal length, and we're going to let W equal width. So we've defined what our 2 variables are that we're going to be using. Okay. So in order to solve the perimeter, okay, we know that perimeter is going to be this plus this plus this plus this. So 2L plus 2W. Okay, so in terms of figuring out the question, okay, we need to be able to find the dimensions. So if we know that perimeter is 2L plus 2W, we would then be able to also say that if our perimeter is 52 centimeters, that 2L plus 2W equals 52 centimeters, or 52 rather, because we're just keeping it as an equation. Okay. We haven't been told any other information for this one. Okay. If we were told though, no, actually we have. We've been told that it is 3 times its width. So we also know for our second equation, the length of a rectangle, so the length of a rectangle is equal to 3 multiplied by W. So we now have our 2 equations. Okay, we can follow the same steps as above to graph both of those equations and find the intersection point. That intersection point will tell us our values. Okay, so remembering that once we know our L and W, we have then figured out our length and width. Okay, so this example sort of just shows you the working out for what we would be doing, or you can do it on your calculators. If you have any questions related to this, I've also put it here actually, just solving simultaneous equations steps that you can have here as a reminder. So to do simultaneous equations on your calculator again, you open a new document with the calculator page, press menu, select 3 algebra, 7 solve system of equations, select 2 solve system of linear equations, put in the number of equations that you have, your variables, remember, have to be separated by a comma, and press OK. Alright, and then you get to type in, it'll leave you some space here to type in your first and second equation. Okay, and then click enter and you will get your X and Y value. Okay, if you have any questions, just leave them in the comments below or send me an email. Goodbye.